Hello, families. So we have moved from adding, subtracting fractions, multiplying fractions, including mixed numbers, and we are now into dividing fractions. So it's at this point of the year that students are really solidifying their understanding of fractions and the operations and how they relate to fractions so that they can then use those skills in seventh to eighth grade and basically from this point moving forward. So they have been introduced to dividing fractions in the past, but not really at any kind of high level of explanation. We started this dividing fractions section or unit or set of lessons with a fairly simple model. So we started off with the idea that you could take a circle and then say we are going to divide this circle up into fourths. And if I had 3/4, let's see, is that white? No. If I had 3/4, this one, and this one, and needed to divide it by 1/4, so it becomes pretty apparent that if we take 3/4 and divide it by 1/4, we can see that I can divide 3/4 into 3 equal 1/4 pieces. And if we're doing a model this way and everything's in the common denominator, dividing fractions doesn't really seem that complicated. However, once we start getting away from having fractions that match up nicely like that, and instead, let's get rid of all that. And instead we ask ourselves, if I had 2/3, and I wanted to know how many times I could fit 1/4 into 2/3, I would see that I've got 1/4 here, I've got another fourth here, and then I don't quite have another fourth here. I have this portion that would fit into my 2/3, but that's not an entire third. So we started, having a discussion in class about our strategy of kind of visually representing division starts to fall apart if the fractions don't fit well together, like halves and fourths or fourths and eighths. So that's why we need something a little bit more complicated. Students will understand later why this more complicated algorithm makes sense. But for now, we just need to understand that we can't really do division well just using a physical model or, just kind of logic. So if I had, like I did before, let's go ahead and change back to white. If I had 3/4 and I wanted to know how many fourths were in 3/4, well, it wouldn't even matter that they were fourths. If I have 3 vans and I want to know how many single vans are in my group of 3 vans, the answer is going to be 3. So 3 of anything divided into 1 of the same thing, you're just counting how many fourths are in 3/4. There's 3 of them, right? But when we have a problem like what we have modeled on the left, which is 2/3 divided by a fourth, our answer gets strange because my group of 2/3 isn't a group of fourths, so I can't just count. I need something more. So that leads us into, well, then what do we do instead? If we can't just divide using a simple visual model or by counting, what do we do? So in mathematics, when we're dividing by a fraction, what you're going to do is you're going to keep the first fraction just the same. Don't change it. That's our dividend. That is the number that our divisor is going to try to go into. We're going to try to partition our dividend into equal pieces of our divisor, however you want to phrase it. Most people say we're going to see how many times 1/4 will go into 2/3. We keep our dividend the same. We change our operation from division to multiplication. That's the inverse operation or opposite operation. And when we do that, we're going to go ahead and use the inverse of our fraction. So basically, we flip the operation and we flip the second fraction. So we go from division to multiplication and from 1/4 to 4/1. If the fraction on the right was 2/4, we would flip it to 4/2 and so on. So then here, your student knows what to do. We multiply straight across. 2 times 4 is 8. 3 times 1 is 3. We go ahead and simplify that improper fraction to 2 and 2/3. 3 goes into 8 twice, so that gives us 2 whole numbers with 2 remainder. So that's still divided by 3, so we get 2/3 there. And if we look at our visual model, we can see that I've got 1/4 here, 2/4 here, and it appears that this section here that's in our 2/3 is about 2/3 of a fourth. We can still kind of see it, but it's definitely not accurate. When we use this keep, change, flip, keep the first fraction, change your operation, flip the second fraction. Most of your students will recognize that. I used to teach my students before I came to James Monroe with just flip and multiply. So you flip the second fraction and multiply instead of dividing. However your student remembers it, this is a process for division. So that takes us to our homework. We've gone over several examples of this in class. Your homework is number 1. Antonio likes to make lattes. He uses 1/3 of a cup of milk in each latte that he makes. So we're trying to figure out how many lattes can Antonio make with the amount of milk given in these 3 different parts, A through C. If there's a remainder, what does that mean? So he has 7/9 cups of milk available, and he needs to divide that by the 1/3 cup that he uses per latte that he makes. So using the method that we had before, we're going to go ahead and change this to 7/9. Dividend stays the same. Division turns into multiplication, and then we flip the second fraction. 3 times 7 is 21. 9 times 1 is 9. 9 goes into 21 twice with 2/9 remainder. I'm sorry, nope, that's 3. Three ninths remainder. That reduces down to 2 1/3, which means Antonio can make 2 1/3 cups of coffee. But since he only makes one size of latte, that 1/3 of a latte that he would make at the end means that he's only making 2 lattes, because he's not going to make a smaller size than the size that he makes with 1/3 cup of milk. So the 2 1/3, this answer here at the end, this represents how many lattes he could make, not how many cups of milk, not how many cups of milk he started with or used. It's 2 1/3 lattes that he makes with the milk given. All right, so that's the first one. Second one, same process. 5/6 divided by 1/3. 5/6 multiplied by 3/1. If you recognize and you remember from high school that you can kind of cross reduce when you're multiplying fractions, and you see the 3 in the numerator and 6 in the denominator, and you want to start reducing right away, that's not a 6th grade standard at this point. So if we can kind of keep things simple for your student, that would be fantastic. So we're just going to multiply straight across. 15/6. 6 goes in twice with 3 left over, twice, and 3/6. Then that reduces down to 2 1/2. So now he can make, with 5/6 cup of milk, he can make 2 1/2 lattes. Again, that half latte means that he would make a smaller latte than his single size. So he's only going to make and serve 2 lattes. Finally, the more difficult of the 3 problems. we have 3 and 2/3 and 2/3 divided by 1/3. Now, this can be handled one of multiple ways. First, and the standard and encouraged method is to change that mixed number into an improper fraction. Then we just use the same algorithm we did before. Another way is to partition this mixed number into two different pieces and asking yourself, how many times does a third go into 3? And then how many times does a third go into 1/3? Breaking up the two pieces apart from each other. So we know if we were to count all of the thirds in the whole number 3, we know we would have 9 of them. And since it's 3 1/3, that's an extra third out there on the side. We divide that by a third, and that will give us one more third. So it appears, just kind of mental math, that we're going to be able to make 10 lattes here. For now, your student, if they're comfortable with that kind of thinking, absolutely go for it. Do it in 2 different parts. If not, let's use the standard method and convert this mixed number into an improper fraction. So 3 times 3 is 9 plus the 1. That gives us 10/3. So 3 1/3 is the same as 10/3. We're going to go ahead and change the operation to multiplication. Flip the second fraction and multiply straight across. 3 times 10 is 30. 3 times 1 is 3. 30 divided by 3 is 10. Antonio can definitely make 10 lattes and use 100% of the milk that he was given because there is no remainder. There's no fractional remainder. So that was problem 1. Problem 2, write a story problem that can be solved using 1 3/4 divided by 1/2. Explain how the calculation matches your story. Now I could say I have 1 3/4 of a pizza to share, but my friends all only eat. Oh, that's awesome. I already started on eat. Only eat 1/2 of a pizza size slices. How many friends can I feed? So there's my story problem. Calculation, explain how the calculation matches your story. If your student can give me a story, that's fine. If they can make any kind of effort explaining how the calculation matches, yeah, I'm totally fine with just a story. Last question. Now, this is just practice. So we're going to go ahead and practice this out. Easy Baking Company makes muffins. They can make several sizes ranging from very small to very large. There are 20 cups of flour in the packages of flour they buy. How many muffins can they make from a package of flour if the muffin takes one of the following amounts? So we're going to take 20 over 1 divided by 1/4. That would then turn into 20 over 1 times 4 over 1. That would give us 80 over 1. That would give us 80 muffins. And that makes sense if we were to break this up visually. If I had 20 whole circles, cut them all up into fourths and counted all of the fourths that went into them, we would end up with 80. I don't know why that's a G. We would end up with 80. Well, if I use twice as much to make the muffin, I should end up with half as many muffins. That would make sense. So for part B, we're going to go 20 over 1 divided by 2/4. Keep the first fraction, 20 over 1, times, flip the second fraction, 4 over 2. Multiply straight across, still end up with 80 in the numerator. This time I end up with 2 in the denominator, and now I have 40 muffins. Interesting. Now we're going to go 3/4. I'm going to switch gears once we get to tenths. So here's 3/4. Same process. 20 over 1 divided by 3/4. 20 over 1. Multiplying now. Flip the second fraction. Now it's 4/3. We still end up with 80 over 3. 80 divided by 3. That's going to give me 20 muffins. It's going to give me 26 muffins with 2/3 left over. Is that right? Yes, it is. 2, 6, 2. Yep, that's it. Muffins. So we'll end up with 26 whole muffins and then enough flour left over to make 2/3 of a muffin. We'll probably throw that away. Now we're on to D. Same process. 20 cups over 1 divided by 1/10 of a cup. Now, 1/10 of a cup is significantly less flour than 1/4 of a cup, so we should make a lot more muffins than 80. Flip and multiply. 20 over 1. We're going to multiply. We're going to flip. This will give us 200 over 1. Yes, absolutely. We can make 200 muffins in this case. You can imagine that twice as many tenths will give us half as many muffins. So I'm going to go ahead and skip that one. 7/10. 20 over 1 divided by 7/10. Flip or keep, change, flip. So keep, change, flip. We end up with 200 divided by 7. And just to make this faster, we're going to grab a calculator, maths tools, calculator. 200 divided by 7. That is going to give us 28 muffins. With 4/7 of a cup left over. Don't forget, I skipped this one. Finally, we're going to do the same thing with 7ths. I think you kind of see the flow here. It's going to be the same process over and over and over again for each of these different cups. The final question, explain how the answers for 20 divided by a 7th, 20 divided by 2/7, and 20 divided by 6/7 are related. Well, if you notice, it's kind of a similar pattern as the previous. If I divide by something like 1/7, I'm going to get an answer. And that answer will be twice as big as the same answer that I would get if I doubled my divisor. So if I divide by, like in this previous example, here if I divide by 1/10, I'm going to get 200 muffins. But if I double the size of my divisor, I'm going to cut in half my answer. So if I double my divisor here from 1/7 to 2/7, whatever my answer is going to be half as big. If I multiply my divisor by 6 times, my answer or my quotient is going to be 1/6 the size of the answer it was before. So if I increase my divisor, I decrease my quotient. If I increase my divisor, if that gets bigger, I'm going to decrease my quotient. So here, if I'm dividing 20 cups of sugar into tenths cups, I'm going to get 200 muffins. But if I do 2/10 cups, I'm only going to get 100 muffins. If I do 5/10 cups, I'm going to get 1/5 the amount of muffins. So whatever multiple of my divisor, that is, flip it over, and that is the fraction of my quotient that I will end up with. So if your student can explain anything like that, any explanation at all, or honestly, for those, if they aren't able to give me an explanation, that's fine. Just show me enough work on the previous problems. I can see your student made an effort and we're in good shape. Sorry for the long video. I think I'm talking more than I need to. So hopefully this helped. Have a good one.